All right, so these are some extra examples of now we're going to solve the inequality. And to do this one, we have to get the absolute value all by itself. So first off, we'll subtract 4 from both sides. So 2 absolute value is 7 minus x, absolute value greater than or equal to a negative 3. Okay. Now we need to get rid of that 2, so we'll divide both sides by 2. And what do we get there? Well, we get the absolute value of 7 minus x is greater than or equal to a negative 3 halves. Okay. Now, when we have greater than, what's going to happen is we're going to split it into or. So that's going to give us 7 minus x is greater than or equal to a negative 3 halves, or 7 minus x is less than or equal to the opposite of that, which is a positive 3 halves. Okay. Now we solve for x, so let's add x to both sides, and let's add 3 halves to both sides. And so when we do that, we're going to have greater than or equal to x, and this is 7. And so if we do that, we're going to have to get a common denominator. So 14 plus 3 is 17 over 2. And that's going to be the first one. Now this one, we're going to do the same thing. We're going to add x, add x. This time we have to subtract 3 halves. So again, that's going to be times 2 over 2. So that's 14 minus 3. So it's going to be 11 over 2 less than or equal to x. And now we'll draw our nice number line. And so, 17 halves is going to be greater than the 11 halves. And again, it's not to scale. It's just, we're just putting marks so we can kind of write what we have. Here it says x is going to be greater than or equal to 11 halves. So at 11 halves, we're going to be greater than or equal to that. So it's going to go that way. Here we say x is less than or equal to 17 halves. Well, that means we're going to be going that way. Okay. Well, it's going to be this or this. Well, this one's going all the way this way, and we go all the way that way. So what do we got? We've got the whole number line. So we're going to go from negative infinity to positive infinity. So we're going over the whole thing. So any number we plug in here is going to work. And if you think about that, no matter what we plug in here, positive or negative, absolute value of that's going to be positive, times 2 is positive, plus 4 more is positive, and that 4 is going to be greater than 1 already. And so no matter what we plug in there, it's going to always give us a true statement. Okay. What about this one? Well, this one we could do the same we did last time, but guess what? We have that x here on this side. What do we do with that? Well, I'm going to suggest we do it graphically again. And so we're going to have some uh, um, graph. We've done this graph already. We know it's at negative 1/2, and it's going up something like this and something like this. And this is going to be y equals negative x plus 6. And so it's going to be kind of higher up. It's going to be, something like that. I don't know where it's crossing again. It's just all hypothetical. But what we need is we need that point. We need that point. And then we also have to figure out what else we need. Oops, we don't want that to be yellow. We want the highlighter to be yellow. And so we want the absolute value to be less than the line. Well, where is that at? Well, that not really a great color, but that's where we want it. Probably should have used a darker one, but that's going to be the area we want to use is that yellow line. And so what we're going to do then is we're going to go over to our calculator and plug in those values. So 2x plus 1, 6 minus x, and we get that. Well, now what are we going to do? Well, we're going to find that intersection again. And so we're going to do a 5, and blue's fine first, red's fine for the second, and our first guess, well, that's going to be our first guess. So we get 1 and 2/3 and 4 and 1/3. Okay. And so we can write that down. Now let's do our other one. And we get 5. Now we're going to go all the way up here. Oh, yeah. First curve, second curve. That's my guess. Negative 7, 13. All right. So that one's an easy one. So I have negative 7, 13. And the other one, If we convert that to fractions, that's going to be 5/3, and that one's going to be 13/3. Okay, so that makes it easier. And so it's less than from, and it's less than or equal to here, so we can actually use brackets, -7 up to 5/3. Okay, so it's going to be equal here as well as here, and everything below. So that then is going to be our solution. And again, when we do this graphically, look how quick we got it. We just had to plot those points and find out what those two intersections were, and we have it. Okay, but I usually try to reserve it for the ones that are harder, that we'd have, a little more difficulty doing, than doing this algebraically and then, getting our two lines like that. So really save this for the ones that are super hard and not easily done. All right, what are we going to do here? Okay, we're going to solve it, and it's going to be inequality. So that's going to be the one where we have, we're going to pick some points, do the positive, negatives, thing like that. So what do we do? Let's subtract 24x. So 9x squared minus 24x plus 16 greater than or equal to 0. Okay. Now, key here is it's greater than or equal to. And so that means our zeros that we find actually can be used as points. Now, what can we think about here? Well, everything's divisible by 3. No, not 3. That's a perfect. Yeah, let's try that. 3x plus 4 and 3x plus 4 greater than or equals 0. So that's going to give us 9x squared plus 12 plus 12. So that's, oops, I don't need plus 4. I need minus 4. So good thing we tested that. Minus 4, so we have minus 12 is minus 24, then plus 16. All right, so that looks like our correct way to factor that. Now we set each of those equal to 0. They're going to be the same thing. So x is equal to 4/3. So 4/3. That's only going to be one point we have. Now we're going to pick some point over here to the left. It's a test. That's our 0. Some point over here. That's a test. Now remember, if we're going to have something to the left, I'm going to choose 0 because 0 is to the left of that. And if I go to the right, that's 1 1/3, so maybe I choose 2. I could choose 4. I could choose whatever. I'm just going to choose something to the right. Okay. Now, plugging those in, 0 here, that's going to be 0, 0. That's going to be 16. It's positive, so it's going to be greater than or equal to 0, so that looks good. Now, here we'd have 9 times 4 minus 2 times, 24 times 2, and then plus 16. That's only going to be minus 48. That's going to be 36. That's going to be 16. So it's going to be a positive no matter what we do. It's going to be a bigger number than 0. And this is going to be equal to 0. And so what we can say is, since it has to be greater than or equal to 0, all of those work. So we're going to say from negative infinity to positive infinity, or if we want, we can say all real numbers. Okay, so everything is going to work again. So no matter what we plug in, we get the correct answer as far as it's going to be true, greater than or equal to 0. All right, so that's all I have. So hopefully that helped.